Security of wireless sensor networks. So, this particular topic has been segmented into two. In the first part, we are going to look at some of the requirements of security in sensor networks and what are the meanings of these requirements of security. And security, first of all, so this is the first part, and the second thereafter we are going to look into different attacks, different types of attacks that are possible in sensor networks, and also very briefly about what are the possible solutions to each of them, but that we are not going to focus more. We are going to focus more on what are the problems rather than the solutions, because security, as you can understand, is a very big topic. It is a vast topic with lot of different aspects, and as such security is so much paramount and it is so much vast that there could be a separate course on security altogether, even for wireless sensor network, even for focusing on wireless sensor networks, there could be a separate course. So, we just have to understand that what are the problems of security in wireless sensor networks, and generally what are the different issues, different types of attacks, and what are the different types of solutions that have been proposed for security in sensor networks. So, so we have to understand a couple of things. So, first of all, what are the important security requirements with respect to things like confidentiality, integrity, availability, which are paramount in terms of requirements of security in any system, including wireless sensor networks. This is number one. Number two is we also have to understand that when we are talking about security in sensor networks, that what are the challenges that are going to arise when we want to establish security mechanisms in these networks, right. So, that means that we have to review, we have to understand that what are the limitations, what are the challenges of these sensor networks, because of which implementation of these security requirements would be difficult. So, this is what we are going to cover in both the first and the second part of this topic of security in sensor networks. So, so first of all, we do not really have to emphasize once again that security is very important. So, we are talking about a network, and in any network, as we know from our basic knowledge, that networks are vulnerable to different types of attacks, be it wired network, be it wireless, even for wireless networks also, even if we are talking about like Wi-Fi or cellular networks, attacks of different types are possible, right. So, this is very important. So, and when we are talking about wireless sensor networks, it's even more vulnerable, because these sensor networks, they are prone to different types of attacks, because it's a wireless medium. Not only it's a wireless medium, but these nodes are very much resource constrained with respect to computation, resource constrained with respect to the memory, limited memory that each of these nodes has, plus energy consumption. That means that they do not have much battery with them, and the solutions that you are going to propose for security in these networks, they have to be very lightweight in all respects, right. So, and at the same time, these networks have to be protected, even in this resource constraint sort of scenario. These networks have to be protected while proposing lightweight solutions that are perfect enough to protect these networks, right. So, so that proper functioning of the network takes place, and there is so what kind of problems can arise in these networks. So, one thing is that the data that are sensed by these different sensor nodes, this data, they can be either dropped maliciously, or the data can be altered, right. So, the data that are sensed by the different nodes, when they are in transit, when the data is in transit through the intermediate nodes to the intended sink node, the data can be altered, the data can be dropped in between maliciously. That means some node which is attacking on the network, so maliciously it basically drops these information. The third thing is that the protocols and the devices means the nodes themselves, they can be compromised, or the protocols, they can be altered. In the communication protocols, they could be altered, so that the intended functionality of these protocols are affected. So, these are the different types of problems that can arise in arise in with respect to security in sensor networks. So, how do you come up with lightweight solutions in a resource constrained environment like this is the whole challenge of security in sensor networks. So, when we talk about security mechanisms, cryptography based mechanisms come into the picture very easily. So, when we talk about cryptography, we are dealing with keys. So, we know that in cryptography there are two types of cryptographic mechanisms. One is called the symmetric key, the other one is the asymmetric key. So, so irrespective of what type of keying mechanism is being used, so keys are very important, and there are basically three types of keying mechanisms that are available for sensor networks. One is the network keying mechanism, where there is a single key that can be used for the entire sensor network. For the entire network, you have a single key. So, basically one thing is that the good thing is that because there is only a single key, you do not this kind of implementation of this kind of network keying mechanisms does not consume too much of resources. So, that is a good part. And as such, you do not even have to have key management based mechanisms that have been proposed for other types of networks. You do not have to have that, but in terms of robustness, these are not very good. So, networking mechanisms are not very good. The second is the pairwise keying, and again, as this name says, that for every pair of sensor nodes, a single key is used and maintained. So, so basically, quite understandably that if the number of nodes in the network is n, then the required number of keys is going to be n minus 1, and it is relatively robust compared to the network keying, because here for every pair of nodes you are using a different key. So, this is the pairwise keying. And the third is like a hybrid kind of it is called group keying. It combines the properties of both network keying and pairwise keying mechanisms. So, a single shared key is used for the network communication, and different keys are used for every pair of sensor nodes. So, it is a hybrid kind of approach using both, and this scheme is more robust compared to the previous ones. Now, as I said before that this wireless sensor networks basically have lot of limitations with respect to the memory, energy, etc., etc. So, first of all, we are talking about in a typical sensor node, we are talking about memory which is just a few kilobytes, and as you can understand that buffering becomes very difficult, and if you are trying to use the traditional cryptographic mechanisms directly, they cannot be used, right. So, because these traditional cryptographic mechanisms, they are memory hungry as well as power or energy hungry. They will consume, they are computationally intensive. Because they are computationally intensive, they are going to consume lot of energy, right. So, these are not very suitable for use in these resource constrained environments. Additionally, there are other limitations as well. Wireless sensor networks are more prone to different types of unpredictability, unpredictable behavior, such as reflection, scattering, fading, etc., which basically leads to huge data loss, bit errors, etc., right. So, unpredictable communication, delay in communication due to the presence of intermediate nodes between two nodes, and because of this particular, because it is a multi hop. So, you have between the source node and the destination node, there are intermediate nodes, and because of which the packet transmission gets delayed, right. So, the third is the remote site and unattended setup of wireless sensor networks. So, typically the nodes, they are unattended, they are not manned by anybody, and additionally these nodes, they are deployed at remote sites for remote monitoring, remote continuous monitoring, etc., and the probability of attacks due to these basically increases. Even the physical attack can also happen. That means the nodes physically can be compromised, right. So, they can be removed, they can be tampered, etc., etc. So, and because they are remotely deployed, they are hard to detect, this kind of tampering and this kind of behavior where the nodes are physically compromised, that would be hard to detect in these networks. Now, I am going to now go through some of the security requirements in wireless sensor networks. So, these are the main requirements. One is confidentiality, integrity, self-organization, newness of data, authentication, time synchronization, secure localization and availability. So, briefly I am going to touch upon each of these requirements. So, when we are talking about confidentiality, so confidentiality, as we know, means that whoever is authorized for the data, that entity should only get access to the data and others should not. The data should be confidential and should not be accessible to any other entity who are not authorized for that data. So, the data should be received by only the intended receiver. The key distribution should be done in a very secret way, and the channel itself should be secure. The channel over which the data is sent, it has to be secure, and that is very important. And without the permission, any nearby nodes should not read the content of the data that is being carried. So, without permission, I mean nobody should, no one else, no other node should be able to get access to the data, should be able to read the data and of course not analyze the data. So, that is data confidentiality. The next one is data integrity. So, integrity, again the dictionary meaning of it applies over here as well. So, the data that is obtained by the sensor nodes and is in transit over the network should not be modified by any third party by any means. And so, the data is being transmitted, the data, the original data from the source to the intended destination node, the base station, etc. The integrity of the data should be maintained. Nobody should be able to modify the data that is in transit. Third is self-organization. Self-organization in ad hoc networks, sensor networks is very important. So, we have a typically dynamic kind of topology, and many things are dynamic by virtue of self-organization, because of which the application of the traditional cryptographic algorithms is difficult. So, traditional cryptographic algorithms like RSA, etc., they assume that the overall topology remains fixed over time and they do not change. And whereas in a self-organizing network, the topology in different ways the topology changes. Physical topology may also change, but due to the sleep scheduling, etc., the logical topology, the virtual topology can also change. And so, because of which the application of traditional cryptographic mechanisms is difficult. So, you cannot use. Data newness, that means that the old data should not be sent repeatedly, and so basically if that is violated, what we have is something called the replay attack. In the replay attack, as we will see later also, basically the same old data periodically it is sent over and over again. So, to overcome this problem, what could be done is to keep a time specific counter which should be added to ensure the freshness of the data. With the time specific counter, it is easily detected whether the data is updated or old data is used. Authentication, data authentication. So, the data that is coming, it should be from an authentic source. It should not happen that anybody can pump in data into the network, right. So, it should be coming from an authentic source. Otherwise, what is going to happen is any malicious entity can come in and throw in data into the network, and that data is basically garbage data. I mean, it's a malicious data, so it should not be used. So, so authentication of the source is very important. Authentication of the source, and just to ensure that the data that is coming is also authentic. Data availability, basically it ensures that the authorized user is not prevented to access the service. Okay, authorized user is not prevented to access the service. So, sensor networks should always be accessible to the legitimate users. Time synchronization is very important. As we can understand that, so we have a distributed kind of environment. The different entities which are participating in the security mechanisms, they should be time synchronized, and so this is a very critical aspect. It needs so the different entities which are participating, they have to be time synchronized in order for the entire processes or the different security mechanisms or the solutions that are deployed to run successfully. Secure localization. You see that localization means that understanding the locations of the different nodes, getting that information. So, in sensor networks, typically the data that is coming has to be geotagged. That means the geographic location of the geographic location of the sensor nodes which are throwing in the data should also be embedded along with the data that is coming in. Otherwise, that data has got no meaning. Now, the problem is that if that is compromised, that means the actual location of the sensor node is not given along with the data. Maybe some other location is given or something like that. That would lead to problems, because so the correct location of the data has to be appended along with the data that is being sent. Now, denial of sleep attacks is another typical aspect of wireless sensor network security in wireless sensor networks. So, basically what happens is this is a kind of denial of service attack where lot of unwanted or garbage packets could be sent into the network, and so these nodes, they are always going to be kept busy and active, and because of which they are not going to go to the sleep state, and they are going to fast consume their limited resources, the energy, etc., and that is one type of unwanted that is one type of an attack which is unwanted. And there are different types of attacks that are specific to wireless sensor networks: routing attack, node replication attack, attacks on information and denial of service. Physical attacks are also possible, and attacks on authentication, attacks on network availability, attacks on integrity, and there are like this. Actually, there are a large number of different types of attacks that are possible for wireless sensor network, and we are now going to go through some of the main attacks on these networks. When we are talking about routing attack, there are a few which are quite popular in the sensor network community. One is called the halo flood attack. The second is the spoofing attack, replay attack, Sybil attack, wormhole attack, selective forwarding, acknowledgement spoofing, compromised nodes attack, and so on. So, these are called the routing attacks. Then we have the node replication attacks, attacks on information that is in transit, and we have denial of service attacks. So, these are the different types of attacks that are possible, different categories of attacks that are possible on any wireless sensor network. Halo flood attack is like this. So, what we have is basically a high power transmitter like this. It is a high power transmitter which basically periodically, not periodically, I mean it is basically successively it will send the halo packets at a very high power, and the intermediate nodes, the nodes which are in the close proximity, then these nodes, they are going to receive the halo packets which assume that basically these nodes are going to assume that these are coming from a legitimate neighboring node, and these nodes, they start communicating with the attacker instead of the actual base station. So, it is coming from a so this particular attacker behaves like a strong powered legitimate neighbor of these nodes, and these nodes, they are fooled in the process, and they would start communicating with the attacker thinking that it is a legitimate node. And this is by doing this, the attacker basically gains control over the entire network. Spoofing attack. So, in spoofing attack, the message itself is altered during transmission. The receiver receives the inaccurate information, and the routing action becomes different, and the data has to travel long distance because of this. And because of this particular thing, unnecessary consumption of energy is going to take place in the entire network, right. So, this is called the spoofing attack. Now, replay attack. In replay attack, as we can see that, let us say that we have the source node and the destination node, and this attacker will come in in between, it intercepts the message and retransmits it in the future. So, what it will do, this attacker will come in between these two nodes, and it will get access to this message that has been sent. It will intercept it, and it will retransmit the data successively in the future. So, this is called the replay attack, and that basically is will consume the limited bandwidth of these networks unnecessarily, because no new data is being sent, and unnecessarily the bandwidth of the network is going to be consumed, and that basically brings the gradually that is going to bring the network down in the short term. Sybil attack. So, in Sybil attack, basically it is sort of like faking a single basically a single sensor node will be like faked as to have multiple identities. So, so basically a single malicious node behaves like multiple nodes, essentially multiple nodes. So, so in this particular case, these malicious nodes, they send several fake messages, and the sensor networks, they are vulnerable to this attack, as the sensor nodes are deployed in very unstructured manner. So, Sybil attack is quite common consequently in these networks. So, here are a few different types of routing attacks that I have mentioned so far. There are few more that I am going to cover in the next part, and here are the references for whatever has been covered so far. Many of them are quite interesting, so one would be encouraged to go through these go through these references that will improve the understanding of security issues in sensor networks. Thank you.